大家好，我叫 Sora，咁咧我就喺 EOK 啦，咁就任教呢個數學科啦，小學到中學嘅 AS level，亦都由 Excel board 咧，其他 Excel board 我都有份教嘅。咁我隔離身邊呢位同事咧就叫阿當。
Hello。
咁佢同一樣咧都教過好多唔同嘅 Excel board 嘅，咁但係佢主要就係負責 IAL Math 第2年嘅 A level 課程啦，亦都有呢個 optional unit 嘅 Mechanics 同埋 Physics 嘅。咁首先一開始我哋非常之感謝咧，Pearson Editor 咁邀請我哋講解呢個 IAL 數學科嘅事前講座嘅。好，咁今日嘅講座咧就會分咗幾個部分嘅。咁首先就係可能有啲同學仔會想由 DSE 轉過去 IAL 嘅，咁所以我都會好簡單咁樣介紹一下 IAL 嗰個遊戲玩法係點樣啦，同 DSE 有咩分別啦。特別係可能有啲同學仔話我有讀 M1-2 或者我冇讀喎，咁會唔會有個優劣喺度咧？我都會講解嘅。咁第二個就係喺 general 啦，即係無論你係讀呢一份卷都好，讀咩 qualifications 都好，喺數學科都應該要留意嘅地方，同埋一啲普遍嘅應試技巧。咁最後一個部分啦，咁我哋就會好針對性咁樣講下每一份卷嘅考試重點啦，一啲 common mistakes 啦。咁我哋今日準備咗好多內容嘅，咁但係因為時間關係，真係講唔晒咁多份卷啦。咁所以咧，我哋就會主要講呢個嘅一定要讀嘅必讀嗰4份卷 P1、2、3、4嘅4份卷啦。咁樣。好，首先我講一講呢個部分啦。你喺咩情況之下你要修讀呢個嘅 IAL Math 咧？睇下你大學想要讀啲咩科啦。咁如果你本身係想讀 Physics 啊、Engineering 啊同 Math 有關嘅科目嘅話咧，咁基本上咧你都係一定要讀 Math 呢一科噶啦。咁特別係如果你想再攻讀 Computer Science、Medicine 呢啲嘅科目嘅話咧，咁大學係會 highly prefer 你本身係有一個 IAL Math 底嘅。可能係未開始讀 IAL， 諗緊要考慮讀嘅話咧，可能你見到個 qualification 就好多種，睇到頭都花，咁我唔知係乜嘢。咁呢度好簡單咁介紹一下。最 general 嗰個 qualification 就係 IAL Math。咁 AS 其實即係半個 A level 咁解。咁但係大學只會睇 A level 啫。所以啦，如果你要讀 IAL Math 嘅話咧，咁 compulsory 你就會有4份卷嘅，咁就係 P1、2、3、4份啦。咁然後你會再搭多2科嘅 optional， 咁就有 M 即係 mechanics 啦 ，S 就會係 statistics， 咁嘅 D 就係 decision 啦。咁然後佢已經幫你組合晒㗎啦，咁所以你就只可以喺呢5個組合裏邊揀其中一個。咁再落到去下邊咧，你見到下一行就會係 IAL Further Math 嘅。咁 IAL Further Math 咧就係如果你想讀呢個嘅話咧，你嘅前提係你一定要讀埋 IAL Math 先嘅，咁即係代表佢會 count 咗你2個 subjects。咁喺 Further Math 裏邊嘅話咧，你見到佢 compulsory 就係得 FP 即係 Further Pure、Further Pure Math 1或者搭一個2或者3咁樣。咁然後 optional 就揀4個。咁但係就唔好忘記，因為佢本身就係前提讀咗個 IAL Math 啊嘛。咁所以其實 total 咧，如果你讀 Math 加 Further Math，你係要讀12個 unit 咁多嘅。咁就係 P1、2、3、4啦 ，FP1 搭一科 FP2 或者3，然後 optional 會有6科嘅。咁如果你見到話，好似真係好多份 paper 喎，我有冇第3個選擇咧？咁係有嘅，有一個 qualifications 就叫做 Pure Math。咁咧喺 Pure Math 裏邊，你就冇得揀 M、S 或者 D。咁佢就係規定你一定要讀 P1、2、3、4、FP1，然後再搭一個 FP2或者3咁樣。咁可能有啲同學仔問，咁其實我係咪真係有必要去讀 Further Math 或者 Pure Math 咧？因為實質嘅情況就係，其實有啲嘅國際學校佢係俾唔到佢哋開唔到 Further Math、Pure Math 呢2科嘅，咁所以變咗其實大學嗰個 qualifications 佢哋嗰個 requirement 佢哋唔會要求你一定會有 Further Math 或者 Pure Math。咁但係咧如果你係讀一啲同 Math highly related 嘅科目嘅話，咁佢哋會 prefer 你有讀更加深嗰啲 Math， 即係 Further Math 或者 Pure Math。你會有一個 advantage 嘅。因為咧 IAL 咧就轉咗做一個新制啦。因為舊制就叫 C1、2、3、4咁樣嘅。咁新制就大概 run 咗1-2年左右啦。咁新制嘅話咧，無論你做邊一科都好，咁就係你每份卷都係會有個半鐘嘅時間去做啦。總分都會係75分嘅。咁大部分都係圍繞住5至7個大 topic 裏邊，咁就問你10至12條題目。當然可以用計數機啦。咁要用啲咩計數機嘅話咧，我之後都會再提到嘅。咁同埋你會有一本 booklet，咁裏邊就會包晒所有嘅 basic formulas 嘅。 咁啊，如果你同呢一個嘅 DSE 比較嘅時候咧，咁其實佢係唔會好似 DSE 咁樣會有分 short credit、long credit，咁就更加唔會有 MC 呢一份卷嘅。咁而佢同 IGCSE 唔同嘅就係講緊話，去到 IAL 嘅話咧，高考嘅話，佢只會集中考你6至8個大 topic 左右。咁所以其實都冇話貼唔貼題呢一樣嘢嘅。咁但係咧調翻轉嚟講嘅就係話，其實佢嗰個 exam style 咧，其實係好 standard 嘅，差唔多年年都係問緊你嗰幾樣嘢，可能係啲數字轉一轉啫。但係佢唔會特登出到啲題目好難，要去刁難啲學生，好似 DSE 咁樣，為咗要分五星嘅話，咁就出啲好深嘅題目。咁呢個情況就唔會喺 IAL 裏邊出現嘅。咁所以換句話說啦，如果你係有充足嘅時間去準備，你喺 IAL 裏邊想攞 A 或者 A star 咧，其實係一件好簡單嘅事。咁當然啦，因為佢每個 topic 都會問到呢條問題嘛。咁既然你唔可以貼題嘅時候，咁即係代表你如果係 M at A 或者 A star 嘅話咧，你係唔可以放棄任何 topic 嘅，係啦，你應該係每一個 topic 都要熟讀佢。嗱，譬如啦，我就拎呢個2020年1月嘅 past paper 做例子啦。咁呢個係 P1 譯卷嚟嘅。咁第一條咧，佢就叫你做一個好簡單嘅 integration 啦。咁啊4分。咁如果一路揭份卷，去到最尾嘅話咧，第11條咁樣。咁係會見到嗱，呢條題目佢就俾一個 f prime prime x 俾你啦。咁啊 part B 嘅話咧，呢個位 part B，咁佢就叫你揾翻個 f(x) 啦。咁你會見到俾一個題目 f prime prime x 俾你，咁其實即係好簡單，叫你 in 2次啦，係咪？咁你見到頭先呢條題目第一條，咁你 in 1次4分，去到第二條唔係第二條，係邊最尾嗰條啦。咁佢叫你 in 2次，咁其實都係8分。係咪？咁其實簡單啲嚟講，佢嗰個 portion 係嗰個比例係差唔多，就唔會存在所謂嘅 short credit、long credit 之分咁樣睇。咁啊，另一點啦，就係講緊話，因為咧喺 IAL 嗰4份卷裏邊咧，其實佢嗰個設計係由淺入深嘅。咁所以有啲 topic，譬如話好似 calculus 咁樣，其實你4份卷你都會見到佢嘅。咁所以如果你話短期之內話，我真係唔夠時間去準備個 exam。我可唔可以放棄某一啲啊？係可以嘅，短期嘅話。咁但係你長期嘅目標嘅話咧，因為你下一份卷你都會見翻同一個 topic，咁所以你都係要搞掂咗呢個 topic，你先可以落下一份卷嘅。呢度啦，如果講到話我真係唔夠時間讀喎，咁點算啊？我應該點樣分？即係點樣決定我放棄啲咩 topic 咧？咁首先第一樣嘢，大家要知道嗰個 grade boundaries 係點樣分佈先啦。咁啊，因為啱啱先 run 咗新制冇幾耐，咁我呢度就攞翻舊制 C1-2 嗰邊個數據，咁啊做咗啲好簡單嘅比較。咁你會見到攞 A 嘅話咧，其實大致上你都要有80%啦，85%就更加穩陣啦。你攞到85% 嘅話咧，就會有 A 啦。咁你落去下一個 grade B 嘅話咧，咁其實就係7成半左右啦，係啦，大約7成半。咁落去 C grade 嘅話咧，咁就係6成半左右。咁啊，我呢度咧都做咗一個表，就係比較翻 P1-2 嘅，係啦，做一個例子。咁其實你見到個數字係差唔多嘅咋，即係你要攞 A 嘅話咧，你攞到85% 就好穩陣啦。咁樣落去，咁然後啦，去到 Grade B 都一樣啦。係啦，咁去到 Grade B 都係一樣啦。係啦，咁然後就係都係6成啦，6成半左右咧，你就可以攞到 Grade B 咁樣去。咁但係唔好忘記份卷其實嚟得75分啊嘛，係咪？咁所以我下一份個表格咧，我就做咗嗱。咁如果真係講緊分數嘅話，咁我要幾多分咧？咁你要見到 A 嘅話咧，其實就大概60分左右啦。咁當然你再攞得高啲就更加穩陣啦。咁你見到落去同 Grade B 比較嘅話咧，其實就爭咗10幾分。落去 C Grade 咧都係一樣爭咗個10幾分。咁啊嗱，你成份卷75分，你大概有10條題目。咁我平均咁照除啦，咁即係代表你有呢一個嘅7.5分左右就一條啦。咁代表緊啲咩咧？就係你嗰個走盞位，你嗰個容錯率咧，其實就係淨係得嗰10零分嘅啫，就係大概1條半至2條左右。如果你錯超過2條嘅話咧，咁你就會俾人掟咗落去下一個 grade 啦。咁呢個要小心啲。咁當然啦，如果你係想講話成個 IAL Math 嗰個 qualifications 呢樣嘢要攞到 A 或者 A star，咁其實 P1-2 嗰個比例就唔係話好重要嘅。其實你應該係要放翻多啲嘅時間去 prepare 你嗰個 P3、P4 呢兩份卷。咁啊，下一個部分啦， 我會好簡單咁樣講一講 IAL 嗰個考試範圍同埋 DSE 嗰個分別。咁啊，如果有啲同學仔話我有讀 M12 或者冇讀 M12，咁嗰個優勢係會喺邊咧？咁呢度我都會講到嘅。咁當然啦，我呢份 table 咧，我就冇講晒所有佢要考嘅嘢。咁譬如話你 Basic Algebra P1，我淨係列咗呢一個嘅 Law of Indices 啦，Sort Operation 咁樣樣啦。咁啊，係代表佢真係會有一條問你齋問嗰個 Law of Indices 咁樣樣，唔代表你唔使識其他 Basic Algebra 啊。OK， 咁所以譬如話你見到我 P2 呢度，我會查咗冇一啲 Basic Algebra， 係代表佢唔會有條問題咁樣問你啦。咁當然你去做緊其他題目嘅時候，你要用到呢一個 technique 啦。咁你會見到呢個 table 啦，其實大部分咧喺 Core Math 裏邊啊，咁即係只要你係 take DSE 嘅話咧，你都會一定學過呢啲 topic 嘅。咁啊，除咗我呢個 highlight 咗嘅係啦，有個 proving。咁呢個 proving 係喺新制嘅 P2 先至出現嘅。咁啊，無論你之前係做 DSE 又好，有冇讀 M12 又好，甚至乎係本身係有 IAL 嘅，其實你睇翻舊制咧，佢會冇呢一類嘅題目。咁呢個一陣間我都會再詳細講嘅。嗱，咁仲有啲乜嘢咧？coordinate geometry 啦，trigonometry 同埋一啲 calculus。咁其實大部分都係 core 嘅話咧，都會見過嘅。咁但係去到 calculus 嘅話，咁就真係冇辦法啦。呢個就只係有讀過 M12 嘅同學仔先會有接觸到嘅範疇嚟嘅。咁所以你話讀咗 M12 係咪有一個優勢？咁係有嘅。咁但係喺 IAL 裏邊，佢本身個設計就係由淺入深。咁如果你一步一步慢慢咁樣學嘅話咧，其實都唔會話好難去 catch up 翻嘅。好啦，咁跟住落嚟，我都會講一講 P3、4同埋 DSE 嘅分別。咁啊喺呢份表裏邊啦，咁有一樣啦，我 highlight 咗 P4 有兩樣嘢，就係一個 proving 啦，同埋 Binomial expansion 裏邊嘅 rational powers。咁呢個又係一樣喺 DSE 裏邊個課程係冇出現過嘅。咁啊Binomial expansion 呢個 rational powers 就係講緊話譬如普通嘅 expansion 可能就係譬如話1加 x to power let's say 3咁樣樣。咁佢 rational powers 佢去到 P4 嘅程度，佢會問你譬如話唔係 power 3啦，可能會係問你 to power -1/2，譬如話咁樣。咁而呢個 log and exponential 咧，咁呢個咧其實喺 core math 裏邊係有出現過嘅。咁但係你唔會見到 textbook 裏邊會特登有一個 chapter 叫做 Linearization 咁樣嘅嘢。咁其實佢係咩嚟咧？純粹就係講緊話我有一個 relationship， 個 x-y 嘅 relationship 本身係一條 curve 嚟嘅，我想將佢變翻做直線，咁就叫 Linearization。咁話喺 DSE 裏邊個題型咧，佢係會有條題目，然後 part A、B、C、D、E 街住你咁樣做，咁你做到最後啦，你會將一條 curve 變翻做一條 straight line 咁樣樣。咁因為呢個 technique 咧，其實喺 physics 裏邊係好常見嘅。咁所以如果本身係有讀 physics 嘅同學仔咧，咁可能會比較熟悉呢一個 topic。好啦，咁啊下一張 slide 啦，下一張 slide 呢度咧，其實你見到頭先 P1、2有出現過㗎，又係 codron 啦、trig 啦同埋 calculus 啦。咁但係佢呢度去到 P3、4咁個程度就會再深啲啦。咁譬如話 differentiation 嘅話，頭先 P1、2其實佢只係 focus 喺一啲好簡單嘅 polynomial 嘅 d 同 n 啦，咁就唔涉及任何 rules 嘅。咁啊，但係去到 P3、4嘅話咧，咁就真係要讀埋 product rule、quotient rule、chain rules 呢一啲，同埋要識得點樣 d 一啲嘅trig functions 咁樣樣。咁啊喺 P4 裏邊有一樣啦。咁喺 coordinate geometry 裏邊會有一個全新嘅 topics， 咁就係個 Cartesian form 呢個位。咁啊遲少少會再講一講 P4 嗰個部分嘅。咁但係簡單啲嚟講啦，呢個就係好簡單比較咗呢個嘅P1、2、3、4同 DSE 嗰個課程分別。咁可能你會見到，我係讀 DSE 嘅，但我見到有啲 topic 咧，頭先嗰個表唔見佢喎。咁係嘅，因為有啲 topic 係真係唔會出現喺 P1、2、3、4裏邊。譬如話啲咩咧？譬如話 proof by MI， 又或者係 differentiation 嗰個 first principle， 呢啲你頭先冇見到嘅。咁但係唔代表你唔會喺其他嘅 paper 見到啊。即係譬如話，可能你會喺翻 FP 嘅卷，甚至係其他嘅 optional units 裏邊會見翻佢嘅。好，咁啊嚟到呢一度啦，就好簡單介紹咗 IAL 嗰個遊戲玩法啦。咁我哋之後咧就真係講翻一啲嘅應試技巧啦。咁啊，呢度主要有3點嘅。好啦，第一樣嘢就係你一定要知道 P1、2、3、4呢4份卷，佢考你嗰個範圍個重點放喺邊度？咩意思咧？譬如話啦，你見到我嗰個 table 啦， 其實你 P1、2、3、4你都會讀 Trigonometry 呢個 topic 嘅。咁但係佢每一份卷考你嗰個重心咧都唔一樣。好啦，譬如話呢一度咧，我就用咗2018年 M2 嘅卷喺 DSE 裏邊嘅，做一個例子。咁你會見到喺 M2 啦，掀咗頭嗰幾版，第3條咧就即刻要叫你做一啲嘅 trick 嘅 solving。好啦，然後咧 Part A 咧你要做 proving 嘅話咧，你都要做一啲compound angle formula。亦都係即刻咧，唔齋即係唔係淨止得 sin、cosine、tangent， 會有埋 cosecant、cotangent 呢啲嘅。咁然後啦，去到 part B 咧，然後再有啲更加複雜嘅一啲 solving 啦。咁啊做到要暈啦，先得個5分，係咪？咁而 P1、2、3、4佢嗰個考核嗰個 focus 點樣唔同法咧？嗱，呢個係2019年10月嘅題目 P1 嘅。P1 嘅 Trigonometry 佢考你嘅咧，其實只不過係好簡單，佢冇任何嘅 identities， 冇任何嘅 proving。只不過係叫你做簡單嘅 sin law、cosine law， 真係全部都同圖形有關，要計啲嘅 area 啊、arc length 啊、perimeter 啊咁樣。咁然後可能再撈埋少少 circles 啊、sector 啊、arc length 呢啲。咁所以咧，其實基本上如果係 DSE 轉過嚟IAL 嘅同學仔嘅話咧，應該係對呢個 P1 應該冇乜問題嘅。好啦，咁落到 P2， 咁 P2 嘅 trick 就做啲乜嘢咧？咁其實就係開始有少少嘅 solving。而喺新制裏邊咧，有時都可能會撈埋其他 topic 一齊問你，譬如話好似呢度 part 2，佢會撈埋個 sequences 咁樣問你。咁但係其實 P2 佢考你嗰個範圍咧，你就係要知道2條式嘅啫。咁就係譬如話sin square x plus cos square x equals to 1，同埋 sin x over cos x equals to tangent x。咁其實佢就係要求你要知道呢2條式嘅啫。咁所以譬如話，本身可能有讀 M1、M2 嘅同學仔，見到part 1呢度，你見到有個 2 theta 減10，可能就會諗啊，我係咪用啲好複雜嘅 compound angle formula 定係啲 double angle formula？ 係完全唔需要嘅，因為嗰個部分係下一張 paper P3 先至會問你。好啦，呢個就係下一個例子，就係講緊話 P3 2019年1月嘅題目。咁啊，呢個係一個非常之 typical 嘅double angle formula嘅 applications 嚟嘅，咁佢就係要求你由呢條式轉翻做呢一個 form 咁樣樣。咁啊，換句話説啦，即係代表你做緊 P3 嘅卷，你當然要用翻 P1、2、3學過嘅嘢啦。咁但係你做 P2 嘅卷咧，絕對唔會用翻你 P3 先至會學嘅技巧。咁所以同學仔咧就要小心啲留意，要知道翻每一份卷考啲乜嘢，咁就唔好亂咁拋書包啦。咁啊，最後啦，咁就會係 P4 嘅卷啦。咁 P4 嘅卷咧，你會見到佢考你嗰個 trick 已經唔係講緊話我要你做一個 solving 或者 proving， 而係你做緊 calculus 嘅時候，係啦 D 或者 in 嘅過程當中，你要用翻你嗰啲 trick 嘅 knowledge 去幫你繼續做。OK， 咁所以呢個啦，用咗 Trigonometry 做咗個例子啦 ，P1、2、3、4。咁所以請大家同學仔要小心啲留意，到底每一份卷考你啲乜嘢咧？都要好清楚知道嘅。好啦，咁呢度就嚟到第2個 study tips 啦。咁啊，唔單止係想自修嘅同學仔要留意啦，就算本身係讀緊 IAL 課程嘅，溫書嘅時候都要留意。就係講緊話啦，你使唔使話真係要 complete 咗成個 chapter 你先至 move on 去下一個 chapter 咧？譬如話，好啦，你開始我而家要自修讀呢個 IAL 啦，你拎住本 textbook 一打開第一課 quadratics。咁我係咪要將 quadratics 由頭到尾熟讀晒佢，好啦，滾瓜爛熟，我先至再 move 翻下一個 chapter 咧？其實係唔需要嘅。咁啊，簡單啲嚟講，譬如話你讀緊 quadratics 同你做 trigonometry 呢2件事係冇衝突噶嘛，係咪？如果你成個星期就咁齋讀 quadratics 嘅話，咁啊悶到傻啦，係咪？咁呢個都係正常嘅。就算係我哋 centre 上堂咧，咁我哋一堂會2個鐘，2個鐘我都唔會俾晒個學生做住同一樣嘢嘅，係啦。因為你中間你轉下其他 topic， 你轉個 mindset 都好緊要。同埋另一樣嘢就係、我自己覺得啦，喺 IAL 裏邊嘅話咧，其實佢會需要你好強嘅一個運算能力嚟嘅。咁你係需要喺唔同嘅地方，你要 gain 多啲 experience。可能你喺某一個位 quadratics 讀到棘住咗，咁然之後去到下棘住咗，咁我但係去咗下一個 chapter。我可能做一啲嘅 Trigonometry 或者 calculus， 咁你嗰日突然間識咗某一啲新嘅 technique， 你調翻轉頭去提翻嘅話咧，咁其實可能突然間你要通咗嘅，係啦。咁所以記住，唔需要將成個 chapter 完成咗佢先至跳去下一步。 第三樣嘢啦，就係講點樣運用呢一個 past paper。咁啊，我哋會強烈建議啲學生唔好一開波就操 past paper。如果你真係對 past paper 有強烈嘅慾望咧，我都會建議你哋都係擺 topic 做。點解咧？你要記住 past paper 咧，佢一份卷，佢只會考你嗰個 topic 1至2條。你做啱個1至2條，唔代表緊你成個 topic 識晒，只不過係咁啱你撞彩撞啱咗。又或者咁啱問咗你一啲你識嘅部分，但係你唔知道原來自己仲有地方唔明白嘅。咁所以咧 past paper 咧，你應該係要當佢做一個真係考核你最後嗰個 level 去到邊度嘅一個工具。咁所以啦，應該係要擺 topic 咁樣做啦。如果可以嘅，揾多啲 exercise 啦。咁 textbook 又好 ，online resources 又好，咁我哋就會 recommend 你，如果係有一啲嘅 dynamic exercise 嘅話咧，咁就更加好啦。咁我幾時先至真係要做 past paper 咧？咁就係你臨考試，你覺得自己已經係 ready 好啦，可以進入考試嗰個狀態，你就開始 by year 咁樣去操。咁然後你做完1年，望一望自己錯邊啲地方，咁就係代表你嗰個 topic 你仲未透徹咯。然後你就翻轉頭溫翻嗰個 topic， 先至再做下一份 past paper。咁同埋另一樣嘢就係，你改自己卷嘅時候咧，應該要對自己非常之嚴格嘅。如果你睇翻 mark scheme 嘅話咧，mark scheme 個instructions 佢會講話，佢會傾向會俾分俾個學生嘅，甚至乎如果個學生佢寫完一堆嘢，覺得自己好似錯喎，咁啊查咗佢，查完之後又諗唔到咁我應該寫咩，咁就咁由得條題目就咁算。咁呢個情況之下咧，其實個 marker 係會睇你寫咗啲乜嘢㗎，你查咗啲乜嘢佢都會俾分，但係你自己去改 past paper 嘅時候咧，應該係要好嚴格。如果你覺得自己嗰個位係落唔到下一個步嘅，係唔 make sense 嘅，你唔應該俾分俾自己，因為你寧願預自己得50分，但係其實你有60分，一定係好過你調翻轉，以為自己60分，但係其實得50分啫，係咪？咁一定係你要考慮到個 worst case， 然後再叫自己做 improvement。OK， 咁啊，記住啦 ，past paper 係一個 limited resources。特別係你轉咗做新制，其實你好難揾到新制嘅 past paper 嘅，咁所以一定要小心咁樣使用 past paper 呢一個 resources。好啦，咁啊下一步啦，我哋呢度咧就會講一啲 P1、2、3、4 4份卷，甚至係其他 optional units 都會好常見嘅一啲錯誤。咁啊呢度咧，我哋就會講一講點樣用你嘅計數機。咁啊記住啦，你一定要同你個計數機做一個好朋友。一定要知道佢可以點樣幫你計數。咁啊喺呢度啦，我會重點講幾樣嘢。第一就係一定要善用你嘅括號，一陣間我會示範嘅。另一個就係啦，有個 storage 嘅 functions 啦 ，history 嘅 function 啦，同埋到底你點樣用你嗰個 answer button 嗰個 answer key。咁啊，我估同學仔咧應該好熟悉左邊呢個 calculator 啦。我估大部分人都應該會用緊呢一個嘅。咁啊，而家嘅 Casio 就有一個新嘅version 啦，就會係右邊呢一個。我脫節太耐啦，我唔知道而家大家係咪用緊右手邊呢個，你又還是仲用緊左手邊呢個？咁啊，甚至乎有啲國際學校咧，可能會要求啲學生買啲好貴成1000幾蚊嘅 graphic calculator。咁到底係咪真係需要啲咁貴嘅 graphic calculator 咧？咁啊，個人而言咧，其實你用呢個最傳統灰色呢隻 calculator 已經好足夠啦。咁啊，嗱，呢度我有一個例子，呢個係 P2 嘅卷嚟嘅。叫你做一個好簡單嘅 integration 啦，就叫你揾翻，我想要揾翻呢個 exact values of 呢個 area region R。咁啊，嗱，留意，因為佢有個 exact area 呢個字眼啦，咁即係代表其實你個答案係會 involve 一啲嘅 irrational numbers 嘅。咁你見到條題目呢度有個 square root 啊嘛，係咪？咁既然你有 square root 嘅話，咁即係代表你嘅答案都會有一個 square root 喺度嘅。咁啊，如果你用緊頭先咧灰色嘅呢一種 calculator 嘅話咧，咁非常之遺憾地，佢出唔到一個 exact values 俾你。咁所以咧，今日我就會教大家點樣用呢個 calculator 幫你 check 你個答案啱唔啱。咁你話咁其他嘅 calculator 可唔可以俾到嗰個嘅 exact values 俾你咧？係有嘅。咁但係可能你篤機嘅時候有少少技巧。咁但係我今日就係講最簡單點樣 check 你嘅答案。因為呢個嘅時間關係啦。咁呢度我就直接 copy 咗個 mark scheme 俾大家睇。咁你 in 咗之後咧，應該會出到呢個橙色我框住呢一個位嘅答案。咁然後因為係一個 definite integral 啦， 咁你就要分別代兩個數去。當 x 係4嘅時候有一個數啦，當 x 係2嘅時候有另一個數。咁你放咗入去咧，兩個數相減，咁就會係你最後個 final answers 啦呢度。咁啊，當你用計數機嘅時候咧，第一樣嘢就係、你應該係將所有每一個 component 拆開一嚿嚿，然後揾個括號括住佢。譬如話呢度負八係個 coefficient， 括住個負八，然後 x 咧你都括住個 x 佢，個 power 個負1 over 2你都應該要括住佢。每一嚿要好清楚睇到放喺個括號裏邊嗰個嘢係乜嘢。好啦，咁啊，然後另一樣嘢就係一個 answer 同埋 execute button， 實質上係點樣運作嘅咧？咁呢度我拍咗段片嘅。咁你要知道咧，其實你撳個 calculator 一撳住 execute 嘅話咧，你個 answer 就變咗做嗰個數。譬如話你見到一路撳啦，咁我最後會撳咗1加3 4。咁你1加3完之後撳住 execute， 你個 answer 就係變咗做4啦。嗱，呢個 answer key 咧就非常之有用嘅。點樣咧？好啦，頭先咧我就話我要將所有嘅數字括起晒佢啦，係咪？每個 component 都括晒入去。咁然後咧，我而家就將 exactly 呢個 format 放入個 calculator 裏邊。嗱，你見到我每一個都括住㗎。而你個 x 咧，你就直接打翻放咗個4落去個 answer 嗰個 answer key， 用翻個 answer key 幫你。好啦，咁呢度一路入啦。嗱，我再 run 多次俾大家睇。個好處就係咧，你成條式入，你可以好清楚睇到自己有冇入錯式。因為咧，實在見咗太多同學仔有唔同嘅篤錯機嘅方法，係啦，簡直係花式錯法。佢哋會做啲咩咧？譬如話，佢會入咗負八，跟住負八就成個 x， 乘完個 x 之後先至再做 power， 咁好明顯咁樣就錯啦，係咪？又或者佢哋好啦都入啱啦，做咗個 x， 跟住條 power 1 over 2，撳一次 execute， 再乘負八，撳一次 execute。咁佢搞咗第一 part 之後咧，咁啊再做第二 part。咁佢哋一路咁樣將啲數字拆得太散嘅時候咧，其實佢哋嗰啲正正負負係攞到亂晒龍嘅。明明個負八佢會走咗去成正八，又或者後邊呢個位5 over 2唔知點解有啲正正負負錯。咁所以記住喺呢啲情況之下，一定係成條式咁樣入晒去，咁你先可以檢查到自己有冇入錯。好啦，咁我哋揾咗呢一個答案啦，負3.375。咁呢個數咧，我哋係可以將佢 store 咗落個計數機嚟嘅。咁啊喺計數機裏邊咧，有呢個 STO 同埋 RCL 呢個掣。咁 STO 其實即係代表 store 咁解，咁 RCL 咧就係講緊 recall 咁解。咁然後可以 store 喺邊度咧？咁就係呢一部計數機咧，其實係有6個 storage 嘅 A、B、C、D、X、Y 呢6個。咁 M 咧其實都係個 storage，但係我哋就唔建議同學仔用 M， 因為佢係有另一個 function 嘅。咁啊，唔知大家知唔知道啦？咁喺計數機裏邊嘅話咧，你見到佢啡色嘅字咧，其實即係代表你要撳個 shift 掣。咁即係代表如果你想 store 數字，你就要撳 shift 係啦，跟住 store 落去 A 度咁嘅樣 store 數字。咁啊，你見到個畫面有個箭嘴 A 嘅話咧，即係代表你已經 store 咗個數落去啦，咁咪放咗入 A 度啦。好嗱，咁啊下一步啦，我哋頭先個 integration 係講緊話由2 in 到4啊嘛，我哋做咗頭嗰 part 啦，放咗個4入去。咁然後啦，我哋要做埋後半 part，就係當 x 係2嘅時候，你嗰個 integral 係乜嘢啊嘛？咁啊，所以呢度啦，我一開始都係撳翻嗱，放個2入去，撳個 execute， 即係代表你個 answer 咧已經變咗做2啦。咁我使唔使再重新入多次頭先嗰條式咧？唔需要，因為你係有 history function 可以用嘅。你撳翻箭嘴咯，一路撳上去，撳上去。嗱，sorry， 嗱呢度再播多次俾大家睇。好啦，撳箭嘴，撳箭嘴。好啦，喺呢個時候你可以再撳多次 execute 㗎。你撳 execute 嗰個時候 ，sorry， 係啦，你撳 execute嗰個時候咧，其實你個 answer 咧，你係會代咗當 x 係2啊，即係你個 answer 你 update 咗個數字啊嘛。係啦，呢一個位，你再撳多次 execute， 你就係再 run 多次呢條式。但係而家你個 answer 已經變咗做第二個數，就係你啱啱 set 咗入去嗰個2。OK， 咁所以留意啦，其實係唔需要重新再入嘅，咁就可以減低你撳錯機嘅機會。咁呢個另外要提一提大家嘅，就係唔好亂咁撳個 on 掣，因為如果你撳咗個 on 嘅話咧，你會 clear 晒所有嘅 history 嘅。咁所以如非必要，唔好亂咁撳個 on，應該要撳 AC 鏟咗個數就夠啦。好啦，咁就一樣啦。 我哋計咗當 x 係2嗰個數字係乜嘢之後咧，就將個數 store 落第二個 storage，let's say B 咁樣嗱 ，shift store 落去 B 咯。我箭嘴指住 B 咧，就代表我已經將呢個答案放咗落去 B 裏邊啦。咁啊，最後啦，我哋就要攞翻個 final answers 啦。咁就 A 減 B。咁咧頭先我所講啦，因為個 calculator 如果呢個顏色咧，其實同上面呢啲 button 咧係對應嘅。你個 A 同 B 係紅色噶嘛，咁所以你就應該撳翻 alpha。alpha A 咁啊減 alpha B。咁你會出到呢一個答案。咁呢個就係計數機幫你計出嚟嗰個數字啦。咁你就比較下咯。如果你計到你嘅答案係4 root 2減37 over 8，你又真係 exactly 喺個計數機打翻你計到嘅答案。嗱，你見到我呢度打嘅時候，我都係括晒啲數字嘅，記住要運用你嘅括號。咁然後啦，你就比較下你寫嗰個答案同你計嗰個答案係咪一模一樣？如果係嘅話，咁即係代表啱咯，係咪？呢個係一個好簡單嘅 checking 嘅方法，但係一定要知道點樣運用你哋嘅計數機。咁當然啦，你用呢個方法嘅前提就係你唔好篤錯機，但係你計啱個數字，然後你 checking 嘅時候唔一樣喎，以為自己計錯數啊，千祈唔好有呢啲低級嘅錯誤。好啦，咁啊講咗咁耐啦，咁啊呢啲係 general 嘅 common mistakes 啊，sorry。咁啊，終於嚟到第3個部分啦。咁呢度咧，我哋就會針對性咁樣講下 P1、2、3、4四份卷裏邊有啲咩地方要特別留意嘅。好啦，首先咧就係 P1。咁啊 P1 卷裏邊嘅話咧，其實 basically 就係分開咗呢5個大 topic 咁樣問你啦，有 algebras 啦、cojom、trig 同埋啲 calculus。咁啊呢度咧你見到 algebras 咧好似佔咗好多分喎。咁其實最主要就係講緊話 algebras 其實佢係包含咗3樣嘢，就係會有呢一個嘅 quadratics、law of indices 同埋 sort operation。咁因為裏邊有3樣嘢，咁所以就會見到加加埋埋都有3至4成左右問你呢一樣嘢。咁啊，但係其實你睇翻個分佈咧，其實好平均嘅，佢真係每一個 topic 都會問你1至2條咁樣樣。嗱，咁今日咧呢度我就會有4個 tips 俾大家。第一樣嘢啦，就係行咗新制 P1 裏邊咧，係會有一啲新嘅 content 嘅，就係講緊 graphs。咁啊，講咩 graph 咧？譬如話一啲嘅 inequalities 啦，一啲嘅 trig functions 啦 ，reciprocal graph 呢啲。如果你睇舊制嘅話咧，你好少會見到啲題目，基本上係唔會叫你做 sketching 嘅。咁但係去到 run 咗呢個新制之後咧，你會見到一啲新嘅題型，譬如話好似呢一個咁樣，2019年6月嘅題目。咁啊，題目俾咗個好 typical 嘅 sine graph 俾你啦。你會見到喺 part B 裏邊，佢會叫你做一啲好簡單嘅 transformation， 然後畫翻 after transformation 嗰條 curve 變咗咩樣。又或者直情係叫你畫一啲其他嘅 trig functions， 譬如話 tangent theta 咁嘅樣。好啦，第二種就係頭先講到 inequalities 啦。如果你係 DSE 嘅同學仔，咁呢啲應該係好熟悉嘅，因為係同緊你哋嘅 linear programming 係一模一樣。咁記住要留意啦，呢個 dotted line 同埋 solid line 係真係有分別嘅，就係講緊有冇個 equal sign 嗰個位。又或者甚至乎佢係圖都唔俾你嘅，就咁俾條色你，甚至係裏邊有啲 unknown 有 unknown key 喺度添，然後就叫你做一個 sketching。咁你要 mark 低曬所有嘅 asymptotes 啦，一啲 intersecting points 嗰個 coordinates。咁啊，由於因為新制先至要有呢類嘅題目，你見 C1-2 咧又唔見喎。咁我要點樣 practice 佢咧？咁如果同學仔真係想睇一啲 past paper 嘅 material， 咁我會推薦大家睇一睇 IGCSE level 嘅 further math 嘅卷，甚至乎係其他 exam board 嘅 additional math， 佢哋都會有類似呢啲咁樣嘅 plotting 啊、sketching 呢啲咁嘅題目嘅。咁啊，第二個 tips 啦，就落去 equation of straight line 咁樣樣。咁啊喺 equation of straight line 或者係 coordinate geometry 啦，籠統咁講。咁啊，眾所周知 coordinate geometry 裏邊係有10萬條式嘅。譬如話你會有 midpoint，有 point of division， 有 distance formula， 係有 eta 式。咁記住你嘅腦容量其實唔係咁大嘅啫，咁你留翻你啲腦容量去記其他嘅嘢。因為呢啲嘅式咧，其實你應該係可以自己 derive 出嚟嘅。譬如話 distance formula 其實同你 Pythagoras 係 exactly 一模一樣。 你唔需要特登背一條式咩 x1 減 x2 all square 加 y blah blah blah， 唔需要記呢啲。你應該係從個 meaning 去記翻嗰條式出嚟。咁啊 ，equation of straight line 呢個 topic， 我通常都只會教個學生兩樣嘢。第一就係 gradient 絕對唔可以揾錯，只係記住 change of y over change of x 呢一條式就得啦。咁就係 y1 減 y2 over x1 減 x2 咯。咁我都唔會特登去背加定減嘅，因為你自己一定會撈亂，所以我就會用 change 呢個字眼。咁話明改變啊嘛 ，change 咁一定係做減㗎，你唔會做加㗎嘛，係咪？咁啊，第二條式就係記住 y 等於 mx 加 c 呢一個 format， 唔需要去記嗰啲咩 two-point form 啊、咩 slope-intercept form 啊，我從來都唔會去記呢啲嘅。只要記得 y 等於 mx 加 c， 你就可以做到所有嘅嘢。譬如話2019年1月嘅題目，咁啊，佢俾一條式俾你啦 ，L1， 咁啊 part A 2分，叫你揾翻個 gradient， 千祈唔好去背嗰啲咩 A、B、C， 跟住唔知咩 B over C 係個 x-intercept、y-intercept、gradient， 唔好咁樣記。呢度係我 example， 其實你要做嘅嘢就係將呢一個 format 做 change of subjects，isolate 個 y 出嚟，你就可以即刻睇得到 y 等於 mx 加 c 嘅 structure。咁係 change of subjects 呢啲係初中嘅程度嚟㗎嘛，係咪？咁你只要識得 isolate 個 y 出嚟嘅話，你一睇 x 前面呢一個 coefficient 就會係個 gradient 㗎啦，已經可以好簡單攞到呢2分。同埋就係、因為如果你揾唔啱呢一個 gradient 咧，你之後嗰個部分咧，你都會連帶一齊錯嘅。咁所以就唔好去背嗰啲咩 A、B、C 嗰啲 shortcut 啦，做翻最基本步 change of subjects。好啦，咁啊 part B 咧，我哋睇翻條題目先。part B 就係講緊話啦，我有另一條線啦 ，L2 同 L1 perpendicular 嘅，然後 passing through 個 point 6負2咁樣。我要你寫個 answer 個 format 都係一樣 y 等於 mx 加 c 嘅。好啦，咁我呢個 solution 就點樣咧？咁既然頭先我哋計咗負3 over 5啦，要同佢 perpendicular 啊嘛，簡單啲就係將佢做 negative reciprocal， 俾翻個負號佢。上下調轉，咁所以就變咗5 over 3啦。然後啦，呢度就佢要 passing through 6負2呢一個 point 啊嘛。你條式我想要 y 等於 mx 加 c， 我哋有 m 啦，我哋知道呢條線會 passing through 6負2呢一個 point， 所以都有 x 同埋有 y。咁我就係爭住個 c 唔知係乜嘢啫。咁喺呢一個位，我亦都強烈建議大家做翻個 change of subjects， 寫翻 c 等於 y 減 mx 先，跟住代啲數字入去。咁你見到我寫嘅時候，我都有好清楚括起晒啲數字。個好處係你真係 exactly 放一樣嘅嘢入個 calculator 度，只要你冇放錯數字，你冇篤錯機嘅話咧，你一定會揾得到啱嘅 C 嘅，就會係負12。因為我實在係見到太多無數嘅學生，佢哋會錯咩咧？第一樣嘢 x y 調轉，呢度有 y 嘛係咪？你個 y 應該係負2，佢哋會放咗6入去。第二個 mistake 就係、如果佢哋唔一開始就做 change of subjects， 好啦，佢放咗呢個 y 係負2之後，咁 mx 乘完之後咧，咁啊就係5 over 3乘6啊嘛，你哋調過去就應該做減啦。唔知做乜嘢咧？佢可能會覺得呢度係一個正數，搬埋過去都依然係正數，咁你咪錯咯。所以我就會建議大家做咗個 change of subject 先，之後先至再放數字入去，篤機計出嚟。你只要嗱，你見到我呢度其實只不過好簡單寫咗幾行，咁我已經係攞足晒頭先嗰5分啦。咁所以記住 math 咧唔係去死背一啲 formula， 而係你真係要 understand 個 meaning， 然後只係記一啲 general 嘅 rules 幫你去做所有嘅題目。好啦，然後呢度就係第3個 study tips， 就係講緊 Trigonometry。咁啊頭先嘅例子都有講過啦，喺 P1 嘅 trick 咧，其實佢只不過係 focus。呢一個嘅真係圖形上嘅計緊 area、perimeter 嗰一啲嘅，咁啊，即係代表你一定要識得 area of circles 啦，係啦，或者係 circumference 嗰條式啦。咁啊，非常之遺憾地咧，如果你睇 formula book 咧，呢幾條式係唔會俾你嘅，佢應該係當咗呢啲係一啲 basic knowledge。咁啊，第一樣嘢唔好撈亂 pi r square 同 2πr 啦。咁至於 sector 呢一個位 theta over 360，其實簡單啲嚟講，即係講話。我將個 circle cut 開佢360份，我而家就攞 theta 咁多份咯，咁所以我先至會做 theta over 360啊嘛，係咪？好啦， 去到 radian， 咁 P1 係會要求大家識 radian measure 嘅。咁喺 radian 裏邊嘅話咧，我會有一個新嘅 formula， 就係 half r square theta。我又使唔使死記呢啲式咧？不需要。咁呢個就係話俾大家聽，你可以點樣 divide 呢條式出嚟咧？呢個應該係大家都知道嘅嘢啦，係咪？咁喺 radian 裏邊 ，pi 即係代表180度啦。你咪將呢個360度轉翻做 2 pi 咯，然後自己做一個約減，你就可以好快得出咗 half r square theta 呢條式啦。去到 circumference 或者 arc length 其實係一模一樣嘅，將360度轉翻做 2 pi， 一約走個2 pi 咧，你就得翻個 r theta， 得出呢條式。咁所以記住唔好亂咁去背嘅 formula， 你背錯咧，你只會成條一齊炒嘅啫。咁啊，依度都好快放一個例子入嚟啦，又係2019年6月嘅。咁啊喺 P1 裏邊咧，依類嘅題型其實係好 standard 嘅，你可以好清楚睇得到會有 sector， 會有 triangles。咁啊，大部分都係將啲 sector 同 triangle 加減嘅啫。咁啊，難度就唔高嘅。咁啊，有一樣嘢要提大家，如果你見到個 triangle 冇90度嘅話，咁當然係用 sin law cosine law 啦。咁但係有90度嘅話咧，你應該係調翻轉題自己。我有90度喎，我可以用翻最基本嘅 sin cosine tangent， 即係講緊話 O over H、A over H 呢個 SOHCAHTOA 呢個部分。同埋，如果你要計一個 area of triangle， 你唔需要用到 half AB sin C 咁複雜嘅。你有90度嘅話，你咪直接底乘高除2咯，係咪？咁啊，如果同學仔話我想做一啲 challenging 啲嘅依類嘅題目，咁有冇啊？有，都係一樣。我會推薦大家望一望 IGCSE level further math， 甚至乎係其他 board 嘅 additional math。咁裏邊咧係會有一紮複雜過呢啲圖10萬倍嘅題目嘅。如果真係想挑戰下嘅話咧，可以去望一望。好啦，咁就呢度係第4個 study tips 啊。咁既然頭先見到個表 algebra 嗰度佔咗咁重，咁不如我就講一講 quadratics 啦。咁喺 quadratics 裏邊嘅話咧，咁啊〜佢考到你個深，即係個深度嘅話咧，只係會 up to discriminant 就完㗎啦。佢唔會有 sum of root、product of root 冇呢啲嘅，喺 P1 卷裏邊嘅話。咁啊呢一條啦，2019年1月嘅題目，咁啊俾咗一條式俾你啦，咁就話俾你聽，呢條式咧係唔會有 real roots 嘅。咁我就問你，咁到底個 C 應該係用乜嘢？咁呢個 format 咧，大家應該要好熟悉，因為呢個應該係要一眼睇得出。佢係一個 quadratic 嘅 formula， 點解咧？quadratic 嘅 format，I mean 係啦。點解咧？我要 get rid of 呢一個 denominator x 嘅時候，咁我自然將全條式乘翻個 x 啦，係咪？你乘 x 嘅時候，呢個負2x 嘅 term 就會變咗做 x square 㗎啦。呢個係一個好 typical 嘅 quadratic format， 一定要認得出。好啦，第二樣嘢，除咗可能有啲學生認唔出呢一個係 quadratic 嘅 format 之外咧。可能佢會見到，咦，我有 5x， 我有 cx， 我有2個 x term 喎，咁我應該點算啊？咁其實只不過你 group 翻個 like terms 咯，你 x 係個 common factor， 然後成個5減 c 就會係你嘅 coefficient。呢個都有好多學生會覺得 confused 嘅地方嘅。咁你個 a、b、c 唔一定係數字㗎，可以 include 一個 unknown， 或者可能直接係一個 expressions 嚟嘅。咁然後啦，條題目話呢條式佢係冇 real roots 啊嘛，所以 discriminant。佢係細過0啦，咁啊，然之後我哋就會開始要 solve 呢個 C 啦，係咪？好啦，咁呢度咧，好明顯咧，你嗰個 root 咧就唔係一個 rational 嚟嘅，一定係 irrational number 嚟㗎啦。咁啊，做到嚟呢個咧，你使唔使 fully expand 佢咧？其實唔需要，你可以直接 take square root。咁但係記住，呢個係第3個 common mistake。你一 take square root 嘅話，總係會有學生唔記得咗一正一負。記住係有一正一負啊，會有正 root 24同埋負 root 24。咁然後你 keep 住一路咁樣 solve 咧，你就會 solve 到個 C 啦。然後第4個咧係一個 concept 上面嘅 mistakes。有啲同學仔可能做到呢度，咦？咁我個 C 我 solve 到咯喎，但佢唔係話冇 real root 咩？咁點解我個 C 會計到數字㗎？呢個係講緊話佢本身呢一條式呢個 equation 唔會有 roots。咁佢唔會有 roots 係 depends on 你個 C 係乜嘢。而令到條式咁樣啊嘛，所以你喺揾翻個 C 嘅過程當中，你會 form 咗一條新嘅 quadratic， 呢條係 quadratic inequality 啦。你條式本身冇 root， 唔代表你呢個新嘅 inequality solve 唔到。 OK 係兩樣嘢嚟嘅，唔好撈亂。好啦，咁啊頭先講咗一紮嘅 P1 嘅卷啦，咁然後接住落嚟咧，我哋就會講下 P2 嘅卷啦。咁啊 P2 咧 in general 咧，咁啊你會見到會多咗幾個大 topic 嘅，咁會多咗 proving 啦，多咗 sequences、exponential 同埋 log。咁啊，但係其他呢啲你見過晒㗎啦，又係 codron 啊、trick 啊、calculus 咁樣樣。你會見到 sequences 呢度咧係佔咗好多 percent 嘅。咁啊，而 proving 呢度咧，頭先我一開始講過話，呢個係一個新嘅 topic 啊嘛，喺新制先會見到嘅。咁但係其實佢考你嘅比例唔係好高嘅，都係得幾個 percent，甚至乎係2020年嘅1月都冇考過。咁啊，所以呢度我就好簡單咁 cut 咗到底 proving 即係考啲乜嘢啊？咁其實就係咁樣咯。冇咩特別嘅，你跟住做嘅話咧，應該都冇咩大問題。因為如果你講話死啦，我真係冇信心喎，我唔知佢做乜嘢喎，又冇 exercise， 係啦，舊制嗰啲卷我又揾唔到，我 skip 咗佢得唔得啊？咁係可以嘅，你自己決定。只不過你要記住，你嗰個容錯率走盞位係大概係1條半至2條左右。你放棄咗呢度嘅話咧，咁你就會減咗4至5分左右。咁你代表其他嘅 topic， 你一定要 cover 翻呢一個損失啊！好，咁啊 sequences 啦，既然頭先見到 sequences 個佔分咁重啦，咁我就講一講 sequences 啦。呢一個係好 typical 嘅題目，好簡單解題，就係講緊話啦。喺2019年啦，咁某一個城市咧，佢個 population 人口咧就係25,000人，佢每一年都會 increase 2%，咁然後因為不斷 increase 啦，一路乘，所以咧佢個 population 係會 form 咗一個 geometric sequence 嘅。好啦 ，part A 佢就叫你揾啊，2032年咁到底佢有幾多人咧？咁啊，2032年，首先第一樣嘢睇清楚條題目，佢有冇問你 total 呢個字眼？因為總係會有學生咧，譬如話 part A， 我係問緊你2032年有幾多個人，但係會有人計錯。由2019年去到2032年 total 有幾多個人？又或者調翻轉，我明明問緊你 total， 但你就係計咗呢個2032年俾我。咁所以要睇清楚條題目個 keywords 有冇 total 呢個字眼。咁 part A 度冇啦，係咪？如果係冇嘅話，咁即係代表唔使計 total。我真係問緊你 exactly 2032年，呢一年有幾多個人？好啦，第二個常犯嘅錯誤就係、如果你睇翻 formula booklet， 你個 nth term 其實就係由你個 first term 開始，就乘你個 common ratio 啦 to power n-1。呢個係你 booklet 一定會見到嘅式嘅。咁但係實質上去到 applications 咧，你未必每一次你都要做減一嘅。點解咧？呢個係 depends on 你點樣 define 你個 first term G1。好啦，譬如話呢條2019年，我會建議學生寫咗頭嗰幾年睇一睇個 pattern。2019年過咗一年，2020啦，咁咪 increase 咗1次2%啦。再去下一年2021年，你就係加咗2次2%。2022年過咗3年，咪 increase 咗3次咯，係咪？如果你係將2019年當咗做 first term， 你嘅2022年其實已經係第4個 term 嚟㗎啦，但係你中間淨係加咗3次 ，OK？如果你將2020年做第一年嘅話咧，即係代表 increase 咗1次叫第一年 ，increase 咗2次第一年，咁係同我頭先講嗰個 situation 係完全唔一樣㗎。咁所以大家應該係要諗清楚，到底你嗰個 G1 define 咗做邊一年，你係應該睇一個 pattern，OK？係啦，譬如話呢一條，咁我點樣做咧？咁你簡單啲睇下，譬如話我呢個例子，2022年同2019年。如果我真係就咁做計數機，2022減2019，咁計到3啦，係咪？呢個3代表咩啊？係講緊話 increase 咗3次，而唔係代表第3個 term 啊。搞清楚呢兩樣嘢。咁所以啦，如果我用翻同一個 pattern 去睇，2032年減翻2019年，又會計到個 difference 係13。呢個13代表緊咩啊？代表緊你 increase 咗13次，而2032年應該係你嘅第14年。OK， 個 index 上一定要搞得好清楚，係啦。同學仔最 confused 嘅部分應該係個 power index 嗰個部分。OK， 好啦，咁啊呢個部分如果冇問題咧，我就 move on 去到呢一個 part B 啦。 咁 Part B 啦，好簡單解題，就係講緊話，咁啊呢個 population 啦，咁啊不斷增加啦每年，咁然後啦，每人咧就會捐5蚊，我就想問啦，咁由2019年去到2032年，咁多年裏邊，總共啲人到底捐咗幾多錢咧？咁樣，咁當然你要揾錢之前咧，就揾咗有幾多個人先啦。嗱，今次咧佢就真係有個 keywords total 啦，所以你應該係揾緊 SN 嘅。好啦 ，SN 又係兩個常犯嘅錯誤。第一就係、你可能會受到頭先 Part A 嗰個 index 嘅問題影響，然後你會覺得呢一個 n， 咁我到底使唔使加一減一㗎？咁即係點啊？記住喺 SN 裏邊，你個 n 就代表你加咗幾多個數。譬如話，如果你想要頭10個 term， 我即係代表個 n 咧都會係10。如果我問你要頭100個 term， 你個 n 都會係100。咁所以啦，2019年至到2032年 total 係會有14年嘅，所以你個 n 都應該係14。好啦，呢個第一個錯。第二個錯就係、唔知點解會做下數咧，佢會將個 power 定咗喺個成個括號1減 r， 呢個係錯啊！記住，你個 power n 只係對應翻你個 r 啫，記住，唔好錯呢一樣嘢啦。咁啊，時間關係啦，我冇辦法解晒成條題目，咁所以我就 move on 去咗下一個部分，就係講緊 Binomial expansion。咁啊 ，Binomial expansion 咧係一啲好值得投資嘅 topic 嘅。咩意思咧？就係講緊話，你只要寫啱個 format， 你篤啱機，係啦，做好你嗰啲括號嘅話咧，你呢4分一定會攞晒。譬如話呢條題目，我會叫你俾一個呢個 expressions 啦，我要你寫翻頭4個 term 出嚟 in ascending powers of x。咁啊，我呢個例子咧，我就寫咗頭3個 term 啫。咁我就會建議大家打直咁樣寫，然後抄晒啲嘢一模一樣先。6c 唔知幾多啦，6c 唔知幾多，抄個2落嚟啦，括住佢，抄埋個負 over 4x， 又係括住佢，唔好漏咗個負號啊！呢度全部都有負號。好啦，打直寫呢個 format 之後，跟住開始填窿窿。你個 c 嗰個位咧，就由最低嘅0開始，0、1、2咁填。然後因為佢要 ascending powers of x 啊嘛，咁所以你個 x 咧都係由0次方開始，0、1、2。咁然後去到第二個 term 呢個位咧，你就用個 power 6最高開始，6、5、4一路咁樣落。只要你寫啱呢一個 format， 括號啲數字放入計數機，你一定會計到啱嘅答案嘅。所以同學仔 train 自己做 Binomial expansion 嘅時候，應該係要 train 你做每一條嘅時候都寫緊一樣嘅 format。你做咗10萬次之後咧，你去到考試做翻一樣嘢，你都可以計翻啱嘅。好，咁啊，呢度我交俾負責 P3 科嘅阿當，同大家講下應試技巧啦。咁因為佢嘅廣東話唔係太流暢，咁所以佢就會講英文嘅。咁我將時間交俾阿當。
Thank you, Sora, and hello everyone. And today I will be going over paper 3 and paper 4 with you guys. Now, for the first few slides, I will be going over a slight overview of the context expected to be in the exam, and I will later on be going over some examples. Now, the examples I picked are examples that I feel that about 60 to 80% of the students will face the same common mistakes, and I'd like to highlight these parts. So without further ado, let's start. Now, in P3, there is going to be a lot of functions. A student is expected to know how to sketch the relevant functions and know how to transform them. As again, in trigonometry, Sora highlighted that it was going to be trigonometry from P1 all the way to P4. Now, all it is just identifying new identities that you wouldn't have seen before in paper 2, such as 1 over secant, 1 over cotangent, and things like that. In addition to this, I will be talking about the double angle formula, and I will have a few examples involving that because I think it's an interesting example. This particular function here, e to the x, and logarithms, I feel they're very closely related to functions because students will now learn how to sketch the e functions and the log functions involving their transformations as well. Now, highlighted here in red is a new topic that was not shown or ever appeared in C3-4. So I will introduce that topic in a bit. As always, with calculus, you cannot escape from it. All the way from P1 to P4, we'll have integration and differentiation. Now, all it is building on the difficulty. So the general rules are still there from the skills that a student have picked up from P1, P2, but we're just including new methods here: product rule, quotient rule, chain rule, and the differential of some not familiar functions that you've seen in P1, P2. Same with integration, integrating some functions that you've never seen before. And finally, the topic in P3 is numerical methods. You'll be given a very nasty function to solve for, which you probably won't be able to, and you'll have to estimate the root using some iteration. Now, a comment. For revision, people going through C3, C4, there aren't any public papers available right now for P3, P4. So for revision, looking back at the old syllabus is a good idea because they are near identical in content. The only difference is when doing C3, C4, please be aware that linearization and proofs will not be seen. Also, doing C3, C4, when you're doing when you see this trapezium rule, you can ignore that because it doesn't turn up in P3, P4. The new topic was linearization. Now, people doing physics would have a very good grasp of it on this because they see it nearly every day. So what I expect will happen is that the student will be given a straight line equation. Now, please note the y-axis and the x-axis aren't as, well, what you expected. And you're supposed to use a straight line equation to estimate some constant parameters in a otherwise not a straight line. So in this particular case here, a student using their P2 skills or P1 skills would be using laws of logs and getting it into a form where it's very, very similar to a y equals mx plus c. Now, look at the y-axis here. So the entire y-axis is ln y. So therefore, this must be the y. The one touching the x here must be the mx here. And finally, we have ln k plus c. Now, the student would have to estimate their gradient themselves, and they might not get a very nice answer. And in fact, it's quite common for there to be about 3 or 4 decimal places. So once you get a numerical value there, you could estimate your LNB and then find a B function, B value, sorry. And also, you look for the y-intercept because y equals mx plus c. This is the y-intercept. Whatever numerical value is there, that's going to be your lnk. Now, in my experience, a lot of students aren't comfortable in sketching functions. It's because they just don't know the general shape or form of a function. So my advice for students starting off is to find the original shape first. Okay, find the original shape and write 4 axes here. And once you have the 4 axes, you're just going to label the relevant, the few reflections, sorry. And this one is reflection on the x, reflection on the y, and a combination of both. After a while, the student would not memorize these shapes anymore. In fact, they'll just memorize the rules. So they'll be like, okay, this is the minus is outside of the f of x, so therefore there must be a reflection in the x-axis. Oh, look at that, the minus is inside the bracket, so therefore it must be a mirror image of a mirror image on the y-axis. With translations, I want you guys to focus on the asymptotes. For those who don't know what asymptote is where a particular value where the function will approach it, but will never touch it. It'll get closer and closer and closer to that particular value, but never equal to it. For this particular example, e to the x, there is a horizontal asymptote at y equals 0. So this e to the x will never have y equaling 0. So I want to investigate how translations affect a horizontal asymptote or a vertical asymptote. For this particular example, this is a translation to the right by 2. As you can see from the translation, there was absolutely no change in the horizontal asymptote. So for any student sketching the new translation, they would start exactly the same location as their previous function. However, a vertical translation by 2 has shifted the entire graph, including the asymptote, by 2. So for any student sketching it, you start at y equals 2 in this case. So before the e to the x function had no vertical asymptote. So let's highlight a function that does have one. The ln x function has a vertical asymptote at x equals 0. So a horizontal translation, of course, will shift the entire graph, including the asymptote, by 2 to the right, and hence you will start from x equals 2. But just like before, there was one that had no effect, and that's the vertical asymptote. So when graph sketching, there are a few questions to ask yourself. Are there any asymptotes? Are there any xy intercepts? Is there a maximum minima? All of these are potential marks in the exam. So if you do forget to label it, you could be losing up to 2 to 3 marks, even though you have the perfect general shape of the graph. So on to an example. I feel a lot of students aren't very comfortable in knowing what a modulus function would do to a graph. So for those who don't know, a modulus function is when you have an input, any number will be the input, but it will always output the positive value. So if the input is -5, then the output will be +5, and whatever number you put in, it will be the exact same number, but the positive version. So I won't be bothering with b here, and in this particular function, they don't actually explicitly say what the function is, they just give you the shape. So what would you do? Now, remember I said that for any numbers going into the modulus here, it would output a positive. So previously, the y-intercept was -3. So at x equals 0, previously it would output -3, but now it would output +3. It is a reflection in the x. As you can see, every single number here is going to be reflected in the x-axis. So just a mirror image for any part of the graph underneath 0. Previously, the asymptote was at -4, so the graph was approaching -4 but never reaching it. But now it's reflected to +4. The graph will now approach +4 and never touch it. But however, any values that were previously positive, well, nothing will happen to it because it will just output the positive value again. But what happens if the modulus is inside it? Well, all it does is that for any values of x that you put in, then it will just output a positive value inside this bracket. So be very careful about the difference here. The general gist is in the previous equation, previous modulus for the entirety of the function is a reflection in the x. For now, inside it, it is just a reflection in the y. Because any value over here, let's say I have, I'm going to put in, previously it was -5. And if I put in -5 here, it will be somewhere up here. But now because I put -5 into this x value here, it will output a +5, and it would have exactly the same y value as +5. Moving on to trigonometry, which I believe is a very large topic in P3. Now, I would like to talk about compound angle first. The identities are given in your formula booklet, but my advice to a lot of students is to memorize them, commit them to memory, because if you're not familiar with them and during the exam, you'll be looking at, well, I don't know, maybe it takes 20 seconds or so, 20 seconds to look through a formula sheet. And that 20 seconds could be used to get an additional mark. So I really want you guys to commit any identities to memory. A typical P3 question would be something like with a sine plus a cos, plus or minus a cos. And this particular question is nice because they tell you to put it in this form. However, a lot of students, when seeing this particular value here, they don't recognize that they'll have to apply into the compound angle form. So majority of my students seeing this one, instead of applying the compound angle form, they will try to move the 4 cos x to the other side and maybe apply sine over cos equals tan to try to reduce these two functions into one function, but they'll find out that they can't. However, applying the compound angle form on this left-hand side would get you, it will reduce it to one function here, which you can solve. So going back to the exam equation, which we'll be doing together. So for any students that don't have their pen and paper ready, please get it. Please note that r is positive here, and they want an exact value for r. So that will be highly likely to be a square root. So always keep your r in a square root when possible. And also alpha is in radians. Finding the r is very straightforward, but the alpha isn't. And later on, I'll be highlighting why it isn't. So first, just a direct expansion of your compound angle found in your formula sheet. We see that sine x is here. We're just making a comparison. So if sine x is here, that must mean the remaining, which is r cos alpha, must equal to 2. And over here, we have cos x. So therefore, -4 must equal to the entirety of the remaining part, which is minus r sine alpha. And the minus signs cancel out. So to find r, all you have to do is r squared equals to 2 squared plus 4 squared. And r equals to root 20. Please remember in the question, r was referring to the positive value only. So that's why I only have the positive. So on to finding your alpha. We will be using the CAST method, which was introduced in paper 1, paper 2. So for any students following who aren't familiar with this particular method, I would advise you guys to put some time on that method because I find it the most, easiest method to solve for any angles. Now, where did I get this tan from? All I did was the blue equation divided by the red equation. Sine over cos, tan, 4 over 2, 2. Now, on to CAST. Because cos is positive, it will be in the or region and the cos region. Sine being positive, sine region, or region. And tan being positive, tan region, and or region. So there is only one region where all 3 angles are consistent with it, and that's the or region. Now, finding the principal angle, as you recall from a CAST, would be to inverse tan the 2. The positive value. And because the region was in the or region, there was nothing to do. So my alpha is 1.11236 big. And here is my final form. Now, this particular exam question didn't really highlight what I really wanted to talk about. So I've made my own example up using this equation right here. So I'm using the same equation. I just decided to make it into r sine x plus alpha instead of it being negative. So just comparing the sine alpha, cos alpha again, I get -4 and -2. Now, because sine is negative, it will be in the tan region and the cos region. Cos being positive, same as before, positive, cos, negative, tan now, sine, cos. Now, look here. There's only one region which is consistent with all 3 of them, and that is the cos region. So you find the principal angle by inversing tan of the positive value. Then you do 2 pi minus, and that is your alpha there. That was for if the question wanted the alpha to be between 0 and 2 pi. It's not uncommon for the question, the exam paper, to ask for alpha between -pi to +pi. So if that was the case, instead of doing 2 pi minusing the principal angle, it'd just be 0 minus the principal angle. Now for another example, but I won't go through it, is highlighting another region here, because I use r cos x plus alpha. And as you can see, it's pi plus the principal angle. Sticking on to trigonometry. Like I said before, I really want you guys to commit the identities to memory. Now, memorizing a lot of things is difficult, and there's only a limited amount that a person can memorize. So whenever you can derive, it will be the best way. So everyone knows sine squared cos squared equals to 1, and people doing P3 would have realized they'd be using this identity and this identity over and over again. And sometimes they make mistakes though. But it takes about 5 seconds during the exam to derive these two out. And all you have to do is start with the most common one, which I hope you guys will never forget, and then starting to divide by sine squared by everything. Divide sine squared, divide sine squared, divide sine squared. This becomes 1. As you remember, cos over sine equals to 1 over tan. 1 over tan equals to cot. So therefore, cos squared over sine squared equals to cot squared. Finally, 1 over sine squared equals cosec squared. And here's an identity that just came about in about 5 seconds of using your pen and paper. The other identity, instead of divide by sine, divide by cos. Tan squared here, 1 sec squared. So why did I make you do this? Because a common question in the exam are proving identities. And I feel that majority of students that come across this aren't really happy with actually doing this question because they don't know where to start. My advice for everyone is to start with the more complicated side. In this on this example, it is the left-hand side. Because if you start with the more complicated side, it offers opportunities to cancel terms. If you cancel terms, it becomes simpler. So it goes from a complex, more complicated side to a more reduced form here. So also with P3 is that they don't want you to use some weird identity that you've never seen before. In fact, they're giving you a hint. In fact, this example is shouting at me to use the cot square formula. So I'm not going to use my brain much. They say, okay, cot squared's here. So we just derived a cot squared identity. So what we're going to do now is just sub in cot squared. And once I've done that, I realized that it offers an opportunity to cancel out some terms. This becomes 1. So I'm left with 1 minus 1 over cosec squared. But if you guys remember, that's equal to sine squared. So I'm left with 1 take away sine squared. And applying the most basic identity, sine squared plus cos squared equals to 1, I would get cos squared. Now, that's only one method to prove this. There are many methods. As long as you use the correct identities and make sure your plus and minus is okay, make sure your algebra is okay, then there's no reason why you can't use a different identity. However, I will warn you guys that sometimes when you pick an identity, which is correct, you'll be left with a situation like this. Now, looking at it is already very nasty because doing this particular form gives you a fraction within a fraction. And in my experience, students aren't very comfortable in manipulating a fraction within a fraction. So let's say a student tries this identity. Once they realize this happens, maybe if they are uncomfortable with their algebra, maybe back out a little bit. Maybe think about a little another example, another identity, sorry. But for any student who feels that their algebra is of the highest quality, then by all means, this shouldn't trouble you at all, and you'll see that you get the final answer as well. I'll just leave this page here for a little bit for students to follow it. and that was P3 over and done with. Unfortunately, due to time constraints, there is no way I can go through every single topic and every single subtopic. So moving on to paper 4 now. Now, paper 4 has a proof section. In particular, it's not just any proof, it's proof by contradiction. Now, for any student not realizing what this is, essentially, you are tasked with a question which is proving this. Let's say proving statement 1. Now, instead of proving statement 1 directly, what you're going to do is assume the opposite. Assume the complete opposite and try and prove the opposite is true. But what would happen is that the moment you work down the maths, right, work through it, you'll find out you'll come to a contradiction. So if there's a contradiction, that must mean somewhere along the line there was an incorrect stage. Now, the incorrect stage would be your assumption. So if your assumption is wrong, then it must mean the opposite is true. And because the opposite is true, you have proved it. Now, every single contradiction by proof will have a different, unique method to solve for it. So for any students who find this topic very difficult to understand, Googling proof by contradiction examples would put out maybe hundreds, I wouldn't say hundreds, that's a bit of a hyperbole, tens and 20s worth of like proof by contradictions. So please have a look on there if you have to, because unfortunately there are no P4 papers out right now, so we can't see what type of questions they're asking. Another topic of study in P4 is partial fractions. This is one of the, I believe, one of the most important topics in P4, and I will spend a lot of time on this later. There are Cartesian and parametric forms, which will be highly likely to lead into calculus, because majority of past paper questions will ask you to find the tangent of this parametric curve or find the area underneath this curve. Binomial expansion, a very systematic process, which I'll be going over later, because there a lot of students make a lot of common mistakes in this one. So I'll be highlighting the mistakes here and hope you guys avoid it. Differentiation, building on from your paper 1 to paper 3, there's no rules here. There's no new rules here. So some application of chain rules and maybe the application of implicit differentiation. It's just building on from P3. There is nothing special about differentiation in P4. However, the integration in paper 4 is, I believe, significantly harder than that of paper 3. There's going to be some new situations where you have to integrate a function times a function, or you have to integrate a really nasty looking function and hopefully you'll break it down to a simpler form. But the one that's going to prove a lot of issues for a lot of the students is differential equations. Unfortunately, I can't go over this with you because it does take a long time, as people who've had experience with it will tell you. Because looking back at your C3-4 paper, if you see a separation of variables question, it is about 11 to 12 marks for one whole question. So it's not uncommon for students to spend about 15 to 20 minutes just talking about this one topic. And finally, vectors, where I'll be later talking about how one vector equation has a relationship with another vector equation. Like I said, partial fractions, I believe, is super important because it would lead into integration or binomial expansion. So let's say a student was revising and they just couldn't understand partial fractions. And during the exam, they were hoping, oh, you know, I'll just ignore the partial fraction part and I'll go do some B parts or C parts, and hopefully I'll get some marks from that. But as you can see here from this 2018 paper, part B is fully dependent on you expressing this particular function into partial fractions. So if your student was willing to lose 3 marks, in fact, you'll be losing 7 marks here, because this one will be very difficult to integrate without you breaking into this partial fractions. Another example of binomial expansion leading on to another topic is here. Once the student has decomposed their particular function into a partial fraction, they will be expected to use this form here on the right-hand side and expand this. As you can see, that's 10 whole marks there. And as you recall from what Sora said, 10 marks is the difference between 2 grades. So you have nowhere else to lose marks if you decide to give up on a partial fraction. So my advice for a lot of students is to please, we have time right now. We still have time until the final exam. Please spend some time getting good and knowing how to decompose partial fractions. So here's a partial fraction form, because when I was a student and I was dealing with partial fractions, I never knew what form to have. But a word of advice, feel free to take a picture of this or screenshot it. However, I would not recommend that anyone memorize this table unless it's like, oh, the day before the exam and you had no other choice. Reason is because there's a pattern emerging. I'm going to call this the base form here. Now, the base form occurs when the power on top is 1 lower than the power on the bottom. The power on the bottom being x squared, power on top being 1. The moment the power goes up to be equal to the power on the bottom, all you have to have is a base form plus a constant polynomial. When the power is 1 time higher than the bottom, all you have to do is base form plus a linear polynomial there. So the pattern's emerging, you can just keep adding up. The next one up, x power 4, would have a quadratic polynomial. Another form that I would like my students to be aware of is this particular form where there's a squared on the bottom. Now, all it is just having that particular term to the power 1 and having that term to the power 2. Have a look. Now, sometimes you pick a form during an exam and you just don't know if you have the correct form. If you remember from the table, then this particular form is for the XQ form. So it's not directly correct, but could you get the correct answer in the end, even if you pick this form? And the answer is yes. If you do attempt to solve for your A, B, C, and D, you'll find out that A would be 0. If A is 0, it reverts back to the original correct form. But that's only if you overshoot. You have a more complicated form than what's expected of it. However, if you don't have the more complicated form and you pick a wrong one, what's going to happen is that when you try to solve for this one, so let's do it together, times left and right by this denominator, left with quadratic over here, cancellation of the x plus 1 here to get x minus 3, cancellation of the x minus 3 to get x plus 1, expand the brackets out, and you will see no matter what values of a and b that could exist, they can never add up to a 3x squared. So hopefully students would realize within maybe 3 minutes they picked the incorrect form because they cannot add up to an x squared form here. So because I have stressed the fact that partial fractions is so important, let's go over one quick example. To solve for this, you have to times both sides by the denominator on the left-hand side, leaving with a whole bunch of cancellations taking place. So over here, we have a quadratic. No cancellations for the A. The x plus 1 cancels with the B, leaving me x minus 3. Cancellation of x plus 1, x minus 3 on the C, leaving me x plus 1. So the method here is to let x be a value such that one of these brackets, or maybe 2 of these brackets, will go towards 0, leaving me with one term that maybe I can solve for. So why don't we let x equals to minus 1? Because if x was equal to minus 1, this entire bracket will go to 0. This entire term will go to 0, leaving me with your b term. Now, once you sub minus 1 into this term, you'll get minus 8. Over here, you get minus 4b, leaving with b equals 2. So we're going to attempt the same technique here. Instead of a minus 1, we're going to do x equals to positive 3, because this will go away, this will go away, leave me with your C term. And you find out C equals to 8. Now, there are no values of x where I can put into this particular right-hand side, that would leave your A term, but remove the B and C. So some students might compare coefficients here, and that's a very good method to use. But I'm going to use another method where I will put a value of x in to solve for your A. Any value of x will do, just as long as it doesn't cancel out any of this term here. So you could use x equals 1 if you fancy it, x equals 2, just not x equals 3. So once you put x equals 0 in, you'll find out that there's a term on the left-hand side, 7, minus 7. And because you have your b's and c's remaining, you know your b's and c's, you can find out the numbers here, and you can solve for your A. So any term will do, just as long as it doesn't remove the x function here, the A function here. So here's the final answer. One tip for you guys. I have seen before students that work really hard and they get the correct answer for your A, B's, and C's. However, at the final line where they have to write the final answer, they put the wrong letter over the bracket. For example, they might put 2 over x minus 3 and 8 over x plus 1. So this is a very, very silly mistake. So I would ask you to spend maybe 2 seconds double checking if that letter was over that particular bracket. Binomial expansion now. It's a very systematic process. What do I mean by that? I mean, if you follow the rules, follow the formula, make sure your signs are correct, make sure your algebra is correct, there is no reason for you to not get very, very high marks on this particular question. However, I must stress that it's very easy to make a mistake in this particular binomial expansion, and I will highlight some common mistakes. So you've already done binomial expansion in paper 2, so here's a brief comparison. Paper 2 terms are finite. You will stop one day, but in paper 4, it'll go on forever. Because it goes on forever, the question can never ask you for descending powers of x. So that's one less thing to worry about. However, in paper 2, it will be ascending or descending. Paper 2's n will be positive integers only. Paper 4, however, will be any rational number. Now, yes, positive numbers, positive integers are rational, but I am 99.999% sure that will never occur, because it will just be such a simple question that is not worth doing in paper 4. Finally, A. A would be any rational number here. However, for paper 4, for binomial expansion, it must be 1, and that's very important. So why don't we look at the past paper from 2020 January? First 4 terms, ascending powers of x, and simplest form. Now, for those who have noticed that this is not the correct form of the binomial expansion, this is not 1. So we have to spend a little bit of time making this form into the correct form of 1 plus kx to the power n. First mistake, a lot of students do know they have to be in 1, so they try to factorize the quarter out. But the thing is, they are not factorizing a quarter out, they should be factorizing a quarter to your power. That's mistake number 1. Mistake number 2 is that they're so focused on taking the quarter out of the constant term, they forget to adjust for the x term here. So that's the second mistake. So please, please, please remember there are 2 things to consider before you even get to this form. Now, finally, because I have this form in the binomial expansion form, I'm just going to apply the formula. For a lot of students, the formula is quite intimidating. Look how many terms there are. I really don't want to mess with that. However, if the student slows down a bit, they might see that it's just patterns emerging. What do I mean by that? The first term is always 1. Second term is the power times your kx. Your kx here is the entirety of minus 12. So your kx is minus 12. So we have the power times your kx. Then the third term is going to be your power times your power minus 1 times your kx bracket whole squared over 2 factorial. For those who have forgotten, factorial is when you have an integer, such as 5, and then you times by every single integer below it. 5 times 4 times 3 times 2 times 1. So 2 factorial would just be 2 times 1. A little tip, this power and this factorial always same number. So that's another check you guys can do to make sure you're on the correct track. The fourth and final term, patterns again, your power times your power minus 1 times your power minus 2 times your brackets kx to the power 3 over 3 factorial. Now, simplifying this is going to be a headache. So a word of warning. Please, please, please keep track of your signs. Look how much it changes. This term wasn't originally negative. Then the next term becomes positive. Next term becomes negative again. Over here, we have a positive, positive, negative, positive, negative, negative. I would say 50% of my students will trip up at this point, and it's a matter of hunting down the correct sign. Okay, but here is the finalized version of this expansion. Now, here's the final most common mistake, is that the students spent a very long time finding this this expansion here. But they forget that they took a factor out right at the beginning. So the actual expansion is this factor times by every single term from the binomial expansion form, which is basically this is a half. So a half times everything inside the brackets. So this is the binomial expansion form for this particular bracket here, and it's only valid for when the magnitude of x is smaller than 1/12. If it wasn't, then this right-hand side equation would diverge to infinity. Vectors now. With vectors, there are a common question for the exam would be to ask what is the relationship between vector 1 and vector 2. Now, there are only 4 things to ask. If they're parallel or not. Are these 2 lines parallel? Are these 2 lines the same line? Do they intersect? Are they skew? So as you would, there's only 2 things to show here. So I, in the example later, showing these 2 things will just give you 6 marks. That is a very high amount of marks for just doing 2 simple things. So how would you know if 2 lines are parallel or not? So this table, parallel, no common point, parallel. Same line, parallel, 1 common point at least. In fact, they're all going to be common, but all you have to show the examiner is that there exists 1 point. Intersecting, not parallel, and only 1 common point, and that's the intersection point. Skew, not parallel, no common point. So that's all you have to show here, okay? So how do I show if 2 lines are parallel or not? If I define vector A and vector B as these coordinates here, I, J, and K, I2, J2, K2, the lines are only parallel if and only if the ratio of all the I ones are the same as the J ones and the K ones. Here, has to be, okay? So once you've shown the examiner if they're parallel or not, maybe we can find a common point. Now, for this particular example here from 2018 January, the question is kind of telling you that they meet already. They meet and there's going to be a point of intersection. So they basically told you what to find. But I can easily change the question saying, hey, show what is the relationship relationship between L1 and L2. So for those who would like to do this question together, you can just copy this equation and we'll just be doing some simultaneous equations. Because essentially that's all it is. I have two unknowns, a lambda here and a mu. And I just need to find out what lambda and mu are to see if there's a common point. So if you expand the brackets out, you'll see that I'll get a system of equations, 3 of them. You only need 2 of them, so keep the third one around for now, but I don't need to use it right now. So you can pick this one or this one if you want to. First equation or bottom equation, I don't mind. But for simplicity's sake, I am going to be using elimination on the first 2 equations to get rid of your lambda. Now, I hope a P3, P4 student should know how to solve by simultaneous equations, so I'm not going to go through it. You find that your mu is -3, and you find that your lambda is -4. Remember, you do not throw this into the third unused equation. You throw it into either your one of the equations that you used. So to show if there is an intersection point, all you have to do is throw this and this into your third equation to see if there's a common point. So in this particular example, I find that in the third equation, I get 8 equals 8. So that must mean my k coordinate is 8. To find out my x and j coordinate, just throw it in your top equation, or throw in the top equation to find out your mu's and find out i's and j's. A word of warning. Let's say the question did not imply that they intersected. Let's say the question was like, what's the relationship? Could it be skew? So if a student's common mistake here is that they find out the mu and lambda and they think they're finished. They think, okay, since I found a mu and lambda here, I must intersect. The lines must intersect, so therefore it must be one common point. However, let's say the question did not imply that they intersected. All you have to do is throw it into the third equation, and if your third equation gets a weird answer out, like 2 equals 7, then it does not intersect. Your k coordinates do not match, so therefore they do not intercept the point at a common point. Okay, so just a word of warning: don't stop at when you find your mu and lambda. Throw it into your third equation no matter what. Integration by parts. Why did I pick this particular topic? It's because a lot of students are intimidated by it. They also don't know what to pick for their U's and your V's. But the general rule is that you look here, you look at your du, you put the u such that if you differentiate it, it becomes a reduced simpler form. However, this is a general rule and not the rule. And later on, I'll be showing you a special case where you cannot do that, okay? So before you start this particular integration by parts, you should write a table of your UV, DU, DV before starting. I'll show you what that table looks like in a bit. So we talked about this one. There's also a special case where I have to apply it twice, which I will be also going over. So the example is from 2018 November. It's actually a quite straightforward one, and that's why it's only worth 3 marks. So which one would you pick as your U? If you pick your U as sine, then your DU would be cos. Now, cos and sine are of the same complexity, so therefore at no point do you have a reduced form. So you pick your U as your X and your DV as your sine. So this is the table I was talking about before I even attempt any formulas from the integration by parts. I have found out my U's, DU's, V's, and DV's. So now there is no need to use your brain anymore, because all you have to do is throw it into the integration by parts formula, as seen here. Now, once you've done that, you see that the second integral, which you have to evaluate yourself, is now a simple function. So you can integrate this quite easily. So tidying this up and finishing off the integral, I'll get something like this. So it's actually quite straightforward after you've done your table. The special case which I'm talking about is ln x here. Whenever I ask a student what the integral of ln x is, they tell me it is 1 over x. But what they told me was the differential of ln x there. So when I do ask them, they don't know. So the tip is to times your ln x by another function here, function of 1. So now it's an integral by parts question. So the integral by parts question, what you're going to do is ask yourself, what is your u and what is your dv? So a lot of you might be thinking, maybe I should pick this as my u, because the differentiated form might be simpler. But then you have to ask yourself, if this is your u, this is your dv. If this is your dv, what's your integral to find v? Well, we went back to step 1. You still have to ask yourself the question, what is the integral of ln x? So why don't we try it a different way? Why don't we make this u, and why don't we make this dv? So here's your table here. We have u equals ln x, d equals 1 over x, v equals x, and dv equals 1. Throw it into that integral by parts formula, and you'll see that is a very straightforward integral to do. And so there's nothing to it. But unfortunately, due to time constraints, I will not be finishing off the example for you. The second special case is when I have to do it 2 times. When you pick this as your u, the differential of that would be 2x, which is great. It becomes a reduced form. If it becomes a reduced form, that's what I'm aiming for, right? You do not pick this as your u because the differential of this one would be e to the x again. So there's no change in complexity. So once you've done that and thrown it in the formula, you will see that there are still 2 functions here. Function 1, 2x, function 2, e to the x. So you can't integrate this directly. So there's not an issue here. All you have to do is just focus on this integral and ask yourself the question, what is your u? What is your dv? As the same as before, 2x is going to be your u, because if you differentiate it, it's going to become 2, a simple form. So we have this form here. So you realize that the second integral is actually quite easy to do. So you have done it. I won't finish this example off for you. So that's left as an exercise. Thank you for listening to our talk. And once again, thanks for Pearson for letting us talk on their platform. Thank you.
係唔該晒 EOK 嘅Don 同埋Sora 幫我哋做咗一個非常之精彩同埋內容非常之豐富嘅 presentation。咁樣而家我哋係一個 Q&A session 嘅，咁大家睇下有冇啲咩問題，可以而家隨便可以你喺個 message box 嗰度講又得，或者喺開咪即場問都得嘅。咁你哋睇下有冇啲咩問題可以問阿 Don 同埋 Sora。
You're welcome, Connie.
係啦，大家有啲咩問題都可以隨便發問嘅。好，咁如果大家趁呢個時間咧諗緊問題嘅時候咧，咁大家都麻煩可以幫我哋填一填個 feedback form 啦。咁我嗰條 link 都擺咗喺個 message box 嗰度㗎啦。你可以用電話 scan 個 QR code 又 OK， 又或者喺個message 嗰度去 click 翻條 link 可以幫我哋填翻嘅。咁如果你填完之後咧，咁我哋其中有個問題係問你想唔想收翻我哋啲相關 information 啊，同埋今日嘅 recording 嘅。咁你填 yes 嘅話咧，咁我哋就會將今日嘅 recording 就會send 翻稍後時間 send 翻去俾你哋嘅。咁係咯，咁我哋都好希望可以有你哋 feedback 啦。
Hello， 我見到有個同學仔問翻嗰個 general study tips。study tips 咧，第一個就係講緊話，你要知道 P1、2、3、4份卷考呢個 focus 喺邊度。因為有啲 topic 咧，你係4份卷佢都會問嘅， 但係佢問嘅內容係完全唔一樣。咁所以你就係喺温書或者你準備考試嘅時候，咁你睇翻到底佢係想考你咩咯？譬如話頭先嘅 presentation 裏邊，我用咗 Trigonometry 做例子嘅 P1 嘅 Trigonometry 係講緊點樣用 sin law、cosine law 撩入一啲 geometry 上面嘅問題。去到 P2、P3 啦，跟住先至係講緊話做一啲 proving 啦、solving 嘅題目咁樣。Okay, very good。好，咁如果同學仔有啲咩問題都歡迎繼續問嘅。Hello，好。咁有個同學仔有問一問，就想知道除咗 past paper 之外，仲有啲咩 exercise 可以練習？咁啊textbook 都係一種啦。又或者係online 嘅 resources 其實都好夠嘅。咁但係我哋其實就會推薦大家做一啲。因為最主要其實你就係要操熟嗰個題型，你係要練到自己見到嗰種題型反射動作，做嗰個方法幫佢 tackle 條題目。咁所以其實你應該要做到一個程度就係、可以係啲題型嚟嚟去去都係嗰幾種嘅啫。咁但係你要知道，當你啲數字改咗唔同嘅題型嘅時候，你會唔會做啲唔小心計錯數嘅情況出現咧？依類嘅型。咁如果可以嘅話，你可以睇下上網有冇啲咁樣嘅 exercise 啦，咁樣咯。睇睇先 ，sufficient 啲。好，等我逐條睇啊。咁啊，有個同學仔就問，咁啊 prepare 呢一個 autumn exam 咁樣。咁啊，而家啱啱開始7月啦，咁7、8、9、10左右啦。係啦，咁啊，其實如果你 efficient 咁樣使用你嘅時間咧，其實係夠時間 prepare exam 嘅。咁當然因為我唔知同學仔佢係 prepare 緊邊一份卷啦，同埋 prepare 幾多份卷，咁我好難即係好難俾一個 general 嘅 solution 實答你話，你一定夠時間嘅，咁我好難咁樣 promise。嗱，咁但係如果你講話，如果普通譬如通常啲同學仔就可能會係 focus 喺 P1、2 咁就一齊考，或者 P3、4 一齊考。如果你講話係 1、2 或者 3、4點都好咧，如果你好善用你嘅時間 ，efficiently 咁樣温書嘅話咧，係一定夠時間嘅。
I also saw Jutta asking a question. Now there are differences. They have the whole setup is also different. They will be doing 3 papers instead of P1 to P4, including some optional ones. And also, it's no longer optional in the UK exam. You have to do mechanics and statistics. There's no way around it. You can't choose it. So, and also there are, but generally, right, I would say 90% of the maths, 95% of the maths that you learn in IAL would be exactly the same as the A level in UK. Because maths doesn't change. No matter where you do maths, they'll be hitting the same topics over and over again. Calculus, trig, straight line equations. However, be very careful though. Some topics which are the same in IAL and A level, there might be a particular skill that is required in, for example, IAL, that is not even tested in A level. But your teachers would be highlighting this point in your A level when you're learning A level in the UK.
有任何問題都歡迎問啊！
我見他先Brian 有講問之前你 miss 咗 physics 嗰個 session， 咁如果你 miss 咗嘅話，其實我哋之後稍後完晒我哋今次呢個 series 個 presentation 之後咧，咁其實我哋都會 upload 翻去我哋個 website 嗰度嘅，咁你可以留意翻我哋個 website， 咁我可以再 share 個 website 喺個 message box 嗰度啦，咁你可以留意翻我哋呢個 website 上面。嗱，啱啱 share 咗條 link 出嚟，咁你哋可以去翻呢個 website 睇翻，之後我哋就會 upload 翻嗰啲 presentation 上去㗎啦。
不過同學仔咧，如果想早啲攞到呢一個 session 嘅話咧，咁都係填我哋嗰個 survey 啦，咁咧就會快少少攞翻咯。因為如果我哋 upload 晒所有嘅 session 上去咧，我哋都要等所有嘅 session 完晒，我哋整理咗咧，然後先 upload 翻嘅。咁如果你填翻而家呢個 survey 啦，咁你就可以快少少攞到。咁同埋我哋亦都會喺下一次有一啲下一個系列啦，或者有其他嘅 subject 嘅時候咧，我哋都會通知咗你哋先嘅。
咁另外都順帶一提啦，咁如果趁而家你哋睇下仲有冇其他問題嘅時候，咁都想提翻大家，我哋今年咧咁個 IAL 個exam 咧就已經開放咗，啲時間表已經有㗎啦 timetable，咁大家可以留意翻HEAA 啦，或者其他啲exam centre 佢哋有得報名嗰啲，咁你哋可以去聯絡翻佢哋睇翻個報名手續啊，又或者個報名時間啊嗰啲嘢。大家仲有冇啲咩問題？
Well, you have our EOK website at the bottom right, and you have to ask Pearson at Excel as well. That will be another method.
係啦，咁如果你哋話想之後再 contact 翻阿 Sora 或者阿 Don 嘅話咧，其實你哋都可以去翻我頭先啱啱 share 出嚟嗰條 link， 我哋個 website 上面咧，其實你哋可以揾翻佢哋個 centre 個名條 link， 咁你佢哋個 website 其實都可以聯絡到佢哋嘅，係 EOK Academy。好，大家啲問題？個 Brian 個 recording 咧嗰條 link 咧就會我之後，如果你哋填咗個 survey 嘅話咧，咁我之後就會 send 翻去你哋 email 嗰度啦。咁如果唔係嘅話咧，呢啲 recording 咧就要等到可能大概8月左右咧，我先會 upload 上我哋個 website 上面嘅。係啦，咁希望大家可以踴躍啲填翻嗰啲 survey 俾我哋啦，因為我哋之後稍後都想準備有多啲唔同嘅 subject 嘅，咁我哋都希望今次睇完你哋個 feedback 之後，睇下有冇啲可以改善嘅地方。係啦，咁其實都仲剩翻唔係好，大家有冇啲咩問題可以把握呢少少時間可以盡量發問。我見到 Helen 問話幾時會有呢啲 talk 嘅，咁我哋都會再籌備嘅。其實我哋過完今次之後咧，再睇翻大家嘅反應係點樣啦，咁我哋就會再聯絡翻唔同嘅老師，咁睇下幾時佢哋有時間可以幫我哋再做。咁所以你填咗個 survey 之後咧，我哋遲啲一有呢啲 session 嘅話咧，我哋都會即時第一時間 send email 通知翻你哋。
仲有冇其他同學有其他問題咧？趁呢個好好嘅機會可以問阿 Sora 同埋阿 Don 喎，因為真係好精彩啦！呢一個咁樣嘅 session 好 detail 啦，俾咗好多 tips 大家啦，同埋啲 study 嘅一啲資料啦，最緊要大家啲 common errors 啦，就自己都要留意翻啦。咁呢個真係一個好 useful 嘅一個 session。咁如果大家都冇特別其他嘅問題，或者之後你哋諗到問題咧，其實都好歡迎你哋 send 翻個 email 俾阿 Wing 啦。咁我哋都會同阿 Sora 同埋阿 Don 咧，佢哋 coordinate 翻睇下會唔會答翻你哋嘅。咁或者你哋亦都可以喺我哋嘅 website 直接去揾到佢哋嘅 contact， 直接聯絡佢哋，睇下佢哋可唔可以幫到手。因為我相信啲同學仔可能話可能我仲需要一啲個別嘅一啲輔導喎，咁都可以直接聯絡佢哋嘅。咁如果你哋冇其他嘅問題咧，咁我哋再一次好多謝 EOK Academy、Don 同埋 Sora 啦，好多謝你哋今日一個好完整、好清楚嘅一個 session 啦，好仔細咁咧，即係好似上咗一堂一個 preparation 嘅一個 section 咁樣樣啦。咁就希望我哋好快又可以同你哋合作，再有下一個 session 嘅。
Grace 仲有條問題。
好，我哋見到條問題啦，就係想睇下呢一個 calculator 個 model 得唔得？我哋 search 下幫你睇下先。因為其實 in general 咧喺Edison 裏邊，佢其實係冇一個 list 話我淨係準你要呢一隻嘅 calculators，佢就調翻轉會有一個 有個instructions 啦，就喺度講話有邊啲 calculator 唔得嘅。咁啊，但係我哋 search 呢一種咧，應該冇問題嘅。你講嗰個 model。好 ，very good。
好，唔該晒咁多位。咁啊，走之前記住填我哋嘅 survey 咯喎。咁啊，如果係我哋希望下一個 session 見到你嘅蹤影。好，多謝晒 ，thank you Don，thank you Sora。
Welcome.
Thank you.
Thank you.
And see you later. Have a good weekend, everybody. Bye bye.
Bye. Bye.